Assalamualaikum and hi everyone. So today we will be presenting about x86 Intel Core i7 architecture. These are my group members. The x86 architecture is based on the CSC design, which features a wide and complex set of instructions, and this case study we're focusing on Core i7. Because of this structure, x86 system include a smaller number of specialized registers rather than many general purpose one, and they rely heavily on complex and specialized instructions. Intel Core i7 processor is a widely used instruction set architecture developed by Intel and compatible with AMD processor. At a high level, the system architecture of an Intel Core i7 base computer consists of three major components. First is central processing unit. This CPU operates based on fetch, decode, execute instruction cycle. Next is the memory subsystem. It's organized in a hierarchical structure to balance speed and capacity. Lastly is input or output subsystem. The I/O subsystem enables communication between the CPU and external devices. An Intel Core i7 is an Intel proprietary processor that is built on the framework of multiprocessor architecture. The Intel Core i7 series contain fast processors that are suitable for more demanding applications and games. The Intel Core i7 processors are available for desktop use as well as for use as a mobile processor like in a notebook. The processor range from the smaller U version to the powerful desktop version with a real consumption. They have integrated graphic unit can also be used for video playback. During this time, the dedicated graphic card can then be put into standby to save energy. The current Intel iGPU support the vast majority of video codecs.
Next, 2.0 is computer architecture. First, ALU. The ALU or arithmetic logic unit handle all mathematical and logic operation inside the CPU. For instance, subtraction, addition, multiplication, division, plus logic like AND or AND not. It take data from register process and send result back. In the Intel Core i7 for super fast high performance computing. Okay, next is control unit or CU to manage data and instruction flow within the CPU. It coordinates the arithmetic logic, unit, register, and the main memory. The CU fetch instruction from memory, decode them, and tell the ALU what to do. It also handle data movement in and out register, ensuring everything flow the fetch, decode, execute cycle. In short, the CU is like a manager. Next is register, key for temporarily storing data for lightning fast processing. In Intel Core i7 x89-64 architecture, there are two types. First, general purpose register, and second, special purpose register. Talking about a general purpose register includes 64-bit, one like RAX, RBX, and also R8 to R50 used for data memory address or temporary result. Special purpose register, which is RIP, for the next instruction address is IR for current instruction, RSP as a stack pointer and reflex for flex, plus XMM or YMM for SIMD, and RSI or RDI for quick memory access, making Core i7 ideal for high performance application. Next, system bus. First, data bus. Data bus have a move data between CPU, RAM, storage, and input/output. First, have a width. Width is determined bit transfer simulation. For example, have a 64 bits. Second, speed. Speed, which is measured in MHz, and the last bidirectional, support a two-way communication. Talking about modern Core i7, use a ring bus for high bandwidth, low latency, which is not all FSB. It enables CPU to run command multitasking for the MI for top performance. Second, address bus. The address bus specific data location in memory or input/output. To carry address only, not data. It will set a max memory, which is Core i7 64-bit, handle high speeds. Pair with QPI for low latency, CPU memory, controller links. This speed large memory access efficiently. Last, control bus. The control bus manage operations like read or write reset, interrupt, and clock between CPU, memory, and input-output. No physical pass, which is used a ring pass, and IMC. In synchronize with data or address pass for fetch, record, execute cycle, boosting multi-core, cache, and multitasking performance. Okay, next, memory and cache. Talking about cache level, L1. L1 is which is used to store frequency access data and instruction to ensure very fast access. L2, store data that is less critical than L1 but still need to be accessed quickly. For L3, store data that is less frequently accessed but still important for overall system performance. Next, talking about cache organization. Intel Core i7 use multi-level cache hierarchy to optimize performance. Cache organization map memory data to cache location via direct method set associative, fully associative technique to reduce latency, improve the access speed. Hit or miss concept crucial for understanding cache function and optimize. Associativity. First, direct method. Each memory block can only be stored in one specific location. Second, set associative divides the cache into several sets and each set can hold multiple lines. Third, fully associative. Each block can be stored in the cache location. So in associative set, associative most used in Core i7. Next, hit and miss concept. Intel Core i7 use cache hit and cache miss concept to manage cache access more efficiently. Cache hit occurs when request CPU data is already in cache, very fast access without main memory reference. So second, cache miss occurs when data is not in cache because CPU receive from slower main memory because delay. Pipeline. Intel Core i7 use circular pipeline for multiple parallel instruction, support by hyper-threading. Pipeline breaks instruction into overlapping stage: fetch, decode, execute, memory, write back. Like assembly line, 40 to 20 stage. Further, out of order ROB 128 to 192, branch prediction, 95% accurate macro fusions. Second, multi-core. Core i7 integrate 4 to 20 core on single idea of parallel processing. Private L1 or L2 per core, share L3, smart cache which is 36 MB, hyperthread double logical core, 20 core which is 28 threads. And the last, parallel processing furthers. Parallel processing use multi-core to execute programs, simulations, speed data processing. Simulation picks data reading, ideal for heavy apps like a video recording and 3D rendering. For example, rendering 10 times faster with multi-core parallel.
Next, we'll be moving on to the instruction cycle. This instruction cycle explains how software applications like playing video games require a large number of individual instructions in order to enable them to run. This instruction needed to be fetched from the memory, decoded, and then executed. During the interruption cycle, interrupts allow the CPU to continue the execution of other instructions while an I/O operation is in progress. When an external device needs an attention, it sends the interrupt signal that temporarily halts the current program so the processor can run the interrupt handler. While during the fetch cycle, the processor fetches the instruction from the memory location that have been appointed by the PC. Later, the instruction will be uploaded to the IR to interpret the instruction and perform the required action. In Core i7 processor, it has an enhancement in branch prediction that increase the speed and optimize macrofusion and microfusion to reduce the latency. Next is the decode phase, where the decode phase is the requirement of the instructions are needed to be worked out by the CPU from the high-level language into a machine language. In Core i7, they implemented the decoded I-cache to help the recycle and reuse prior decoded instruction to save more power and less heat consumption. While during the execute cycle, the CPU will carry out the instruction that was fetched. Action like performing a calculation or flow to the main memory to retrieve data from a different location. In Intel Core i7 processor, it has a clock cycle that have multiple parallel pipelines that are used to ensure the micro-ops execute efficiently and proceed to fix the latency. Okay, next we'll be talking about the internal CPU operation while each stages are operated. Firstly, we'll be talking about the fetch phase. During this phase, the program is stored to be in the main memory. Next, the address of the next instruction is supposedly retrieved, is copied to the MAR. Then the signal sent to the control bus is sent to the control CU to main memory. Then the obtained data from the main memory is fetched to the MDR through the database. And finally, a copy of the instruction is stored in IR. While during the decode phase, if the instruction involves an operation to be performed by the ALU, the required operands are to be fetched. This is done by sending its address to the MAR and initiating the read cycle. And finally, the operands are read from the memory into the MDR and transferred from MDR to ALU. Last but not least, during the execute phase, the ALU will perform the desired operation. If the result is to be stored, it is sent to the MDR. And then the address of the location where the result is to be stored is sent to the MAR and the write cycle is initiated. And finally, the content of the PC are incremented, so the PC now points to the next instruction to be executed.
That concludes our presentation, and in conclusion, the Intel Core i7 is a high-performance processor series developed by Intel and is designed for use in both desktop computers and laptops that require strong computing power. This processor is equipped with multiple core and threads, allowing it to handle several tasks simultaneously with high efficiency and smooth performance. Compared to lower-type processor, the Intel Core i7 offers faster processing speed and supports Intel Turbo Boost technology, which automatically increases the processor's clock speed when additional performance is needed, such as during gaming, video editing, software development, or other demanding applications.